Hello again, boys and girls. It's Mr. Pancholi here. Hope you're well. Let's welcome to lesson 2. And as a starter, I'd like you to have a go at this exam question, which covers some of the work we did last lesson about states of matter. It's a 6-mark question, so ideally give yourselves up to 6 minutes to have a go at this. Answer as fully as you can. Think about this as an exam and how you'd answer it. So pause the video. Give yourself as much time as you can, maximum 6 minutes, and we'll have a look at the answer in a second. Okay, so this is the answer or something similar that you should have got. I've highlighted some of the ones that I think are most easiest to remember, but obviously you think about how you've answered it and see if it matches up with this. So with solids, the particles are close together, vibrate about a fixed point, they have strong forces of attraction and they're held together strongly. Whereas gases, the particles are far apart. They move randomly, there's no force of attraction between them, they spread out in all directions. Any 6 of those would give you the 6 marks. Okay. So today's lesson is about density, and you've got the fact book in front of you with density. And they should, there's about six or seven facts in that. I'd like you to have a think of this lesson as answering or reinforcing those facts. So by the end of the lesson, you'll know and you'll be able to define what density means. You'll know the units for density. You'll be able to describe some experiments to calculate density for regular, irregular objects and liquids. And you'll be able to explain why some objects float while others sink. So let's think what density means. The definition for density is the amount of mass in a given amount of volume. The unit for density is kilograms per meter cubed, or kilograms per cubic meter. There are other units we can use for density. For example, you can have grams per centimeter cubed. That would work as well, because grams per centimeter cubed is the same ratio as kilograms per meter cubed, so the answer you would get is the same as long as it's kilograms per meter cubed or grams per centimeter cubed. Density tells us how tightly material is packed together in an object. But to work out density, we need the mass and the volume. So what do they mean? Mass is the amount of stuff, the amount of particles in a material. The unit for mass is kilograms, and it's measured using balance scales. So if I asked you to find the mass of something, you would get some balance scales, put it on the scales, read off, and it would give you the value in grams or kilograms. Volume is the amount of space inside a 3D container or 3D shape. It's measured in cubic meters, so m with the 3 above it. Another way of saying that is meters cubed. Think about this. Here's a car park with some yellow cars parked in. I'd like you to compare this car park with this car park. Which one would you say is more dense? Give yourself a minute to pause the video and just answer in a sentence which one of these is more dense, the red car park or the yellow car park, and give a reason for your answer. I would say the yellow car park is more dense because there are more cars, which represent the mass, in the same amount of space, which represents the volume. Whereas in this scenario, we've got fewer cars, so less mass in the same amount of space. The amount of space of the car parks doesn't change. The amount of stuff inside it does. The more stuff in the same amount of space, the more dense something is. And just a reminder, I do forget to say this, with this slide, if you want to pause it and copy down, there's some important stuff on here, the definition of density and also the definition of mass and volume. So pause the video and copy these down, please. Here's the equation for density. These are one of the equations that you need to be able to use in the exam. You'll notice here that density has a letter P. In fact, that's actually not the letter P. That's a Greek symbol called rho. So density equals the mass divided by the volume. The way we say that is mass per volume. Please copy this down. This is an important formula. Okay, some students like to use formula triangles. So, formula triangles are useful when we need to rearrange the formula. For example, the formula for density is mass divided by volume. But what about if we need to find out the mass and we're given the density and volume? Or perhaps we need to find the volume when we're given the density and mass. In this scenario, it'll be good to use a formula triangle as follows. If you want to use it, if you want to pause the video and copy it, by all means do so. Just a reminder how to use a formula triangle. You cover up the thing that you would like to find. So in this scenario, if I want to find the mass, I cover the mass, and I'm left with density times volume. How about if I want to find the density? Well, you'll notice cover density, and it's mass divided by volume. What about if I want to find the volume? Cover volume, and it's mass divided by density equals volume. Just a reminder, when we're writing equations, always have two sides, always have something, and then the equal sign, and then the other side of it. So mass divided by density equals volume. That completes the equation. And that's just the equations in green at the top rearranged to give for density, mass, and volume. Pause the video if you want to, you can copy that out. I'd like you to spend 5 minutes, pause the video and have a go at completing these calculations that practice the equation for density. If you need to, you can always look at your density equation, but the further down you go, try to practice using this without looking at the equation. Pause the video and have a go at these. Density is a measure of how much mass there is in a volume, mass per volume. What are the units for density? Well, as I mentioned before, you can have kilograms per meter cubed or grams per centimeter cubed. What about number 3? What did you get for that? You should have got mass divided by, 0.02. So you should have done mass divided by density, 5 divided by 250, which gives us 0.02 cubic meters. And number 4, mass of 45 grams fills a space of 15 centimeters cubed. You may notice in this scenario, rather than kilograms and meters cubed, we're using grams and centimeters cubed. The density is mass divided by volume, which gives us 45 divided by 15 equals 3 grams per centimeter cubed. And completing the table, using that formula triangle if you want to do so, these are the answers you should have got. In your answer book, if you've got anything wrong, please do correct them. It's best to have the correct answers in front of you, so if you go back to revise them, you'll know how you got there. Okay, moving on. Last lesson we talked about states of matter. We discussed the properties of solids, liquids, and gases. And we talked about the idea that the particles in a solid are very tight together. Liquids, they're still touching, but they can move over each other, and gases, they're very far apart. That property of how they're arranged, particles, also leads us to determine the density. So we can say solids are the most dense state. We can see that because if you think about the square, the white square as being the same size for all three, clearly solids have the most particle, or the most number of particles, in that same space. So we can say that they have the most mass per volume, which is density. Liquids are less dense than solids, but more dense than gases. There are fewer particles in solids, so they have less mass per volume. Gases, on the other hand, are the least dense. There are far fewer particles in the same amount of space, so they have less mass per volume, they are least dense. If you would like to do so, pause the video and copy this information out. Okay, now this stage we're going to be looking at the required practicals for calculating density. We're working out density for different types of objects, and the first one we're going to look at is the density of regular shaped objects. But to do that, we will need to work out how to find the volume of regular shaped objects. One thing I want to point out is, in maths, the definition of the word regular is different to how we say it here. In this scenario, regular just means we can easily find the volume of objects. So for cubes and cuboids, for example A and B, we can find the amount of space inside them, the volume, by multiplying the three dimensions together: the length, the width, and the height. To be honest with you, it doesn't matter which one you choose for which you choose for length, width, and height, as long as you've multiplied the three different angles together. So, three different sides together, sorry. So in A, for example, we've got a cube. The sides are 1 by 1 by 1. In that scenario, 1 times 1 times 1, we can say the volume is 1 meter cubed. Whereas in B, we just multiply the three sides together, so it's 2.5 multiplied by 1 multiplied by 1, which tells us that the volume is 2.5 meters cubed. At the bottom, we've got a cylinder and a sphere. D is a sphere. And I've written the equations to calculate the volume for those there. If you would like to do so, if you haven't remembered those from maths, then by all means, pause the video and copy those equations down. In science, if you are asked to find the volume of a cylinder and a sphere, usually you're given the equation to use, but just in case it's there. So, a regular shaped object is one where you can find the density of it quite easily by finding the volume. What you need for this one is a ruler to find the sides, a digital balance scale to find the mass, and regular shaped objects that you want to find the density of. And the method is as follows. You would measure the length, the width, the height, as we showed in the previous slide, and you'd record them, and you'd make sure you use a ruler for this to be accurate. You then calculate and record the volume. Different formulas are required for different regular shapes. Then you'd find the mass of each object by using the balance scales and record the results. That's very important. Mass is only found by using the scales. Finally, calculate the density with the information you've just recorded. You've recorded the mass by weighing on the scales, and you've recorded the volume by calculating using the height or the radius, and the density equals mass divided by volume. To help you out there, I've linked a website that on YouTube that shows this practical in detail. I'm going to end the video here, and we'll have a part 2 with the second and third required practicals and some further information. So please look out for part 2 straight after this video.